Okay, at least we're going to show. Okay, so basis being a linearly independent set that spans whatever the space is, we want to show whether this set spans R2. Okay? Now, let me make a geometric connection, because you always want to keep the geometric connections in mind. 1, 2 looks like this, and 2, 1 looks like this. Take any vector in R2, and you can find a multiple of this one to add to a multiple of this one. Uniquely, it gives you that vector. So if you want, and we did this, we did this, 6 weeks ago. So if I want this vector, what do? Well, I move along this vector. I'm just going to do this quickly because we've done it. Okay? Until I'm at a point where a vector in this direction intersects that line. Then I have two multiples. I have this vector and this vector, right? So if this is V1 and this is V2, or yeah, I could say that's, okay. I'll just say this is C1 times the vector 2, 1, and this is C2 times the vector. Actually, since this was listed first, I'm going to want to use subscript 1 in this one. You don't have to do that, it's just easier to look at. Use whatever. Okay? So this is some multiple of this one, and this is a multiple of this one, right? So there's a picture. And now letting V1 stand for this one and V2 for this one, there's V1, there's V2, right? C1 V1 plus C2 V2 is C1 times 1, 2 plus C2 multiplied by 2, 1, right? And that equals this vector here. We'll call this vector V. Okay. Now, that is equivalent, and you really have to totally understand this and should have a little better on the major quiz. This is just the product 1, 2, 2, 1 multiplied by C1, C2, and I hope this has become second nature to you. If it hasn't, pronto, make it so. You have to see this is the same as this, and you don't just memorize it. When I see this, I write this. You understand why this is this. And of course you can understand that backwards. If I multiply the first row by this, I get C1 times 1, 2, right? And I multiply the second row and all that stuff. Oh well, if I multiply it out, that's what I get. Okay? I didn't really say that right. But, okay, and if V is XY,
because a lot of times, unless it's a reputable,
or let's say X1, X2.
And for instance, we could not find Carolina Reapers.
Okay. Then this equation becomes this. So we'll say V, and we'll say that V is, we don't know what X1 and X2 are. It could be any X1 and X2. It could be any vector anywhere in the plane, right? So we're not going to worry about what the specific coordinates of this vector are, what the specific C1 is, or what the specific C2 is. We're just going to prove that we can always find a C1 and C2 that solves this equation. Okay? So,
Amazon. Again, I mean, if I heard
V1, V2 spans R2 if and only if, and I'm going to give you some notation here. This could be for any. That's an upside down A. It stands for all or for any.
39 cents a seat, you all. Just to show you that this C project could be
When you say 10 seats, then I meant 20.
Any vector x1, x2 in R2, this equation has a solution.
It is weird.
But I'll say there exists,
Shop around.
for any x1, x2 in R2, there exists C1 and C2 such that C1 V1 plus C2 V2 equals,
Genetic variability in the plant provenance is really important. Where that seed comes from is better.
X1,
Especially for,
X2.
like, pollinators
Okay.
and stuff like that. They're
Probably should have used V in there somewhere, but
They want the genetics
Okay.
of their parents. You know, to maybe come back to the same population as plants. Not great.
So my weather, it's pretty, that's worse than what we saw in Houston.
34 is low for Abingdon, so if you're in some cases higher elevation, it's probably be cooler. Some cases lower elevation, you got clear seams. Like you're next to a river.
Frost pockets.
Yeah, you get these cross pockets. Danger, danger, danger. Working on my feet.
Okay. And this occurs, for the present example,
Oh, is it?
if and only if this always has a solution for C1 and C2. Okay? Now, what is it that determines whether this always has a solution?
All right, well, any other questions? Well, that actually probably is Monday morning, really, Sunday night, Sunday night. Really, that's probably that close. Yeah, check old. You never know. You get wrong, you might not, but better be safe than sorry, right? And you also,
If and only if this is invertible. If this is invertible, you multiply both sides by the inverse and you get your solution for C1 and C2. I'm not going to go back and say why that is, because that's something that we did a long time ago. If you don't understand that, review, make sure that you do understand. Okay? And what's the what's the easiest way to test if this is invertible?
Determinant.
Sorry, can't hear.
The determinant is not zero. If the determinant.
You said, oh, you said determinant. So I had to hear that word. Yeah. Okay? So, we'll make it as a statement.
all right, so we made it through.
Make that bracket look a little more brackety. Not totally messy, but okay. Invertible if and only if the determinant's not zero. Well, determinant's negative 3.
Need to go over anything before that?
So the determinant,
We have here. It's green, it's got briars.
determinant's negative 3, which isn't 0, so it's invertible. Okay?
Notice, I would put SP if you're only looking at one, but I noticed we have different color on each shape, so
So we have a basis. Okay? Now, actually, I kind of made a big leap there. So